Distributed Hashing Tables by Kayla Smith, Tashima Chester, and Kyron Bush. Introduction to Distributed Hashing Tables, referred to as DHTs. Decentralized data stored that can find its data by using key value pairs. Each node is tied to specific keys and the values associated with those particular keys. Hashing functions is used to create the keys that uniquely identify with associated data values. It can be used to handle large volumes of data, and the data can be in any form, so it offers great performance. The multiple nodes allows it to provide fast access. It's tolerant because if a node fails, the data is inherited. It's reliable. When a node fails, a new node is added. And it's scalable because it can function well even with multiple nodes being added. DHT's flow. Data is put through a hash function using a key, and it's stored in hash tables, and applications can look up the request.
What problems do distributed hashing tables solve? DHTs provide an easy way to retrieve information from a substantial collection of data. The data type uses a method of keys and values to identify elements quickly. Hash tables compute in constant time, which is the fastest execution time for an algorithm. There are many methods to implement hashing tables, which means they are suitable for many different scenarios. For instance, they can be implemented using multiplication or division. This algorithm can help find duplicates in a large data set and quickly retrieve those elements from said dataset. Overall, distributed hash tables are one of the more efficient algorithms for database management, and although they can become troublesome when collisions occur, compared to other algorithms in most situations, they reign supreme. Limitations of distributed hashing tables. DHTs suffer from a computing phenomenon called database degradation. If there are too many collisions within the table, the system will slowly degrade. The issue becomes more prevalent when more data is added, as larger amounts of data incur the risk of collisions. Hashing tables do not allow null values or keys, which can become problematic in certain situations. Group and range queries are extremely difficult to implement with hash tables. Altogether, if the algorithm is not written efficiently, many problems can occur, which can degrade the system over time. Additionally, DHTs run in constant time. However, when more data is added, the time increases, which makes them less efficient than other computing algorithms.
During real-world implementations, the address space is typically 128-bit or 160-bit key space. The key K is possibly a hash of a file's data rather than the file's name to ensure content addressable storage so that users can find it if renamed. Reliability can be added by using redundancy. For example, K as the key and the data stored in more than one node corresponding to the key. Instead of just selecting one node, real-world DHT algorithms select I suitable nodes, with I being an implementation-specific parameter of the DHT. In some design, nodes are set to handle a key space range. The size is chosen dynamically instead of being hard-coded. Most machines sending messages is more expensive than using local hash tables, so they bundle many messages for a particular node into a single batch. This can be done using bucket sort, where n is the number of nodes in the DHT. Temporary local hash tables are used to do this implementation. Ultimately, the operations are sent to the respective nodes.
Here is an example of the distributed hash tables. Here is the code explanation. First, we declare the hash table variable using the hash table data type by using keyword new. The name of the variable defines is ht. Then add elements to the hash table using the add method. You need to add both a key and a variable element when adding something to the hash table. 3. There is no direct way to display the elements of a hash table. In order to display the hash table, you first need to get the list of keys 1, 2, 3, 0, 0, 1, 0, 0, 2, and 0, 0, 3. From the hash table, this is done via the rcollection interface. This is a special data type which can be used to store the keys of a hash table collection. Then assign the keys of the hash table collection to the variable keys. 4. Next, for each key variable, we get the associated variable in the hash table by using the statement htk. This is how we create a hash table, add the elements to the hash table, and display them accordingly. Conclusion: what we learned. Why it is used. Distributed hash table provide an easy way to find information in a large collection of data because all keys are in a consistent format and the entire set of keys can be partitioned in a way that allows fast indication on where the key/value pair resides. What is DHT? A distributed hash table is a data store that looks up data based on key value pairs. Every node in a distributed hash table is responsible for a set of keys and their associated values. The key is a unique indicator for associated data value, created by running the value through a hashing function. The data value can be many forms of data. Camilla-based distributed hash table is used for effective alert transportation and distributed fusion of similar alerts. In order to minimize false alarm rate, event corroboration is used to find similarity between events diffused by different detection sensors.
In conclusion, here are our citations. IEE Transactions on Parallel and Distributed Systems, January 2020, Volume 31, Issue 1, page 37 through 250. IEE Access, IEE Duffel Distributed Hash Tables and Why They Are Better Than Blockchain for Exchanging Health Records. In conclusion, we would like to say that we really enjoyed this semester and we've learned a lot as it relates to data structure. Thank you.